Section 4.5 is on quadratic equations. Wherever the graph of a function f of x crosses the x-axis, f of x is equal to 0. So where the graph of any function crosses the x-axis, the y-coordinate at that point is going to be 0. The value of x at that point is called a zero of the function. So to find the zeros of a quadratic function, f of x equals ax squared plus bx plus c, we need to solve the related equation, ax squared plus bx plus c equals 0, because I want to know when is f of x equal to 0. Several different ways you can do this, one of which is by factoring and using what's called the zero product property. It basically says that if you're multiplying two things and you get a 0, then one of them, or maybe both of them, has to equal 0. So let's use that and solve a quadratic equation by factoring. So here we have x squared plus 3x minus 18 equals 0. So factoring that, I'm going to be looking for two numbers that multiply to negative 18 and add to a negative 3. So those numbers would be 6 and negative 3. So that factors into x plus 6 times x minus 3 equals 0. Zero product property says that if I'm multiplying these two things, I have to take into account that either one of those could equal 0. So set each of those binomials equal to 0. So x is equal to negative 6 or x is equal to 3. So what does that mean? That means that the quadratic function f of x equals x squared plus 3x minus 18 is going to cross, the graph of that is going to cross the x-axis at the point x equals negative 6 and the point x equals 3. I could do a real simple sketch here of that for you. So if that's 3, and let's say that is negative 6, the graph of my quadratic is going to look something like this. And that's not super exact. And these points right here are called the zeros, or the solutions of that equation. Now, as long as we're talking about graphing, you can also solve a quadratic equation by using a table on your graphing calculator. The solutions are going to be the x values when the table shows you that y is equal to 0. So here's an example. Solve 10x squared plus 2x minus 46 equals x minus 4 by using a table. In order to make this happen, I need to have the whole thing equal to 0. So I'll subtract x on each side and add 4 on each side. So that's going to give me 10x squared plus x minus 42 equals 0. So I'm going to graph the related function, or put the related function into my calculator for 10x squared, or y equals 10x squared plus x minus 42. And I already did that here, so I've put that into the y equals of my calculator. And even though we're not quite at graphing yet, I'm curious. I'm going to hit the graph button and see what happens. Oh, cool. So it doesn't fit on here, obviously, because my y-intercept is going to be a negative 42, which is like way the heck down here. But I can see that there is a certain parabolic shape to this. And I'm going to have a 0 right here. Oh, it's not letting me write on that. But anyway, you get the idea. And I'm going to have a 0 right in here. Okay, so let's go to our table. Remember that second graph. And I started putting in some values that were to the left of that point. Let's go here. So I'm going to put in x equals negative 3, and I'm just going to go all the way up and see if I get any zeros. So when I put in x equals negative 3, I get that y is 45. When I put in x equals negative 2, I get y is negative 4. That's interesting, because between 45 and negative 4 on the number line, there's a 0 in there. So there's a 0 somewhere between negative 3 and negative 2. And if I continue down my table, I see that I actually have a 0 right here where x equals 2. So that's one of my solutions. But what I really need to do is figure out what is my x when y over here is going to be 0. So let's just try a couple different numbers here. Let's try negative 2.5. Let's try halfway in between. Negative 2.5. And that's going to give me 18. That's still closer to negative 3, the value for negative 3. So let's try a negative 2.3. Getting closer to 0, but not quite there yet. Let's try a negative 2.2. Getting closer to 0, but not there yet. And let's try a negative 2.1. And sure enough, that gives me my 0. So my two zeros from the table are going to be x equals 2 and x equals negative 2.1. Now, to be honest, solving a quadratic equation using a table is not super precise. Probably factoring is one of the best ways. There are also other ways, but let's take a look now at how we can solve a quadratic equation by graphing. As we just saw, we're going to look for the x value where the graph crosses the x-axis. So I need to write this so that it's equal to 0, so that's going to be 5x squared minus 18x minus 8 equals 0. And I'm going to go ahead and put that in my calculator. Okay, so when I put this into my calculator, I put it into y1, 5x squared minus 18x minus 8, and when I hit graph, I don't get my full parabola, but you can kind of see the idea of what's going on here. So I'm going to have 1 0 right here where it crosses the x-axis and another 0 over here. Actually, that one looks like it could be exactly 4. So let's go to our table and check that. So if I go to my table, and I do have 4 in here. If not, I could just enter a 4. Yeah, so one of my zeros is going to be 4 because when y is 0, x is 4. But I don't have the other one. I'm going to show you a little trick to, oops, that's not what I wanted. A little trick to do that. Let's look at the graph again. So I'm going for this point right here. I can actually use something in the calculate menu here. So I'm going to do second, trace, and you'll see that 0 is one of my options. So I'm going to select 0. And then you'll see here it's asking me for my left bound. So I want to put my blinky cursor somewhere to the left of this 0, which is actually going to be somewhere up here above the x-axis. So I'm going to move my cursor. There we go, that'll work. Or I could put it one more. I could put it there. So that is to the left of my 0. So I'm going to hit enter. Now it's asking me for the right bound, so I'm going to put my cursor somewhere down here. Might even actually have to go off the, oh, that'll work. Okay, so that is to the right, so I'm going to hit enter, and you'll notice that my calculator, yours may not, it actually drew 2 vertical lines that kind of are between where my 0 is. And now it's asking me to guess, so if I just hit enter again, it tells me that at that point, and you'll notice the blinky cursor move there, x is equal to negative 0.4 and y is equal to 0, so my other 0 is a negative 0.4. So by graphing, I saw that x was equal to 4 and x was equal to a negative 0.4. And our last example here is a word problem. And it says the function f of x equals negative 0.002x squared plus 0.77x models the path of a baseball where f of x gives the height of the ball and x gives the distance from where it is hit in feet. So the first thing says, how far does the ball travel before hitting the ground? In other words, what is x? What is the distance when y equals 0? In other words, what is the distance the ball has traveled when its height is 0? In other words, when it is on the ground. So in order to do that, I think I'm going to graph this one because what I want to do is find, see what the graph of this looks like. Okay, so here I've put the function into my calculator, negative 0.002x squared plus 0.77x, and I want to see what the graph of this looks like. So when I hit graph, and I had a normal like negative 10 to 10 window set up, it almost looks like it's drawing a line, which is kind of a bother, but you can see they're a little offset here, so it's not quite a line, and I know this has to be a parabola that opens downwards. So I think I'm just on a part of it where it is so almost linear. I need to get a bigger picture here, so I'm going to need to change my window. So I'm going to hit the window button on the top here. And to be honest, I played with this a little bit, and sometimes you just have to play with it, and I discovered that if my x minimum is a negative 100 and my x maximum is 400, and because that's, I don't want 500 tick marks on my screen, I'm going to say make my x scale 100. So in other words, every little tick mark on the x-axis is going to be at 100. Same thing with my y. I played with it a little bit and I realized I wanted a y minimum of 100, a y maximum of y minimum of negative 100, y max of positive 100, and let's go with a scale of 10. And now when I graph this, it should look a little more parabolic. Perfect. So remember what this is talking about. Your y is the height of the ball, okay, and your x is the distance from where the ball was hit. So when the ball is hit at the very beginning, it goes through 0, 0, so it has no height, and the ball is basically where it started. But then as the ball is hit, it gets to its maximum point up here in terms of height, and then it continues, the distance continues, and down here is where it hits the ground. So what I really want to know is, I don't care about 0, 0, because I know before the ball is hit, it hasn't traveled any distance and it's on the ground, or close to it. But after the ball is hit, I want to know, what is the x-coordinate right here? What is the distance right there? So I can do what I did earlier and go to second trace. I can use my calc, and I'm going to be looking for my calculate menu. I'm going to be looking for a 0, and the 0 that I want is the one over here. So I'm just going to move my cursor. Let's move it a little bit closer. Actually, I could leave it anywhere here. Moves a little slowly. So let's go for that. Let's hit enter. And now that's my left bound. Now I want my right bound. It's got to be all the way over here. So this is going to unfortunately probably take a little bit of time to move it all the way over there. I'm going to pause here. Hold on. Okay, so I've moved my cursor so that it is on the other side, or kind of to the right of where my 0 is. So I'll hit enter to enter that as my right bound, and then I will hit enter again, and it should tell me that this point right here is the point 385, 0. So the ball has traveled 385 feet when it hits the ground. So when y is 0, x is equal to 385 feet. Okay, second question says, how high does the ball go? Well, let's go back to our graph here. And so in other words, I want to know, what is my y coordinate at this point right here? So again, I can use my calculate menu, so second trace, and this time I'm going to want the maximum value. So I'll select maximum, and it wants a left bound. So I need to put the cursor somewhere over here to the left of the maximum, which I'll do right now. Okay, so I have my cursor to the left of my maximum point, so I'll hit enter. And now I need to set up my right bound, so I need to move my cursor over to somewhere to the right of my maximum value. I think this just ends up taking a long time because I have so many, because my graph is so big actually. Okay, that's clearly to the right of my vertex. So as soon as it stops moving there, okay, I'll hit enter again. And there it's set up the boundary. This one's actually a little easier to see. So what it's going to be doing is looking for what is the highest point between those two lines. It says guess, so let's hit enter again. It's going to take a few minutes to think. And it tells me that my maximum value, my vertex, is the point 192.5, and my y value is 74.1125, a little more than 74. So how high does the ball go? It goes approximately 74 feet. And then my last question is, what is a reasonable domain and range for this function? Well, if you remember, my x-coordinates went from 0, 0 to the point 385, 0. So a good value for the domain would be between 0 and 385. And a reasonable range would be between 0, and I'll put my y in there, and remember it was a little more than 74, so I'm going to say about 75. Okay, it was just a little bit more than 74, but I couldn't get an exact number there. So in this section we took a look at ways to solve finding the zeros of quadratic functions by solving the related quadratic equation. We did that by factoring using the zero product property. We did that by making a table, which isn't super precise and can be a little tedious. But the really cool thing we did was we solved the quadratic equation by graphing on our graphing calculator and finding the x value where the graph crosses the x-axis, because at that point f of x is equal to 0.